What if I told you that you could spot a dangerous poison in our water with just a little vial of liquid and your smartphone? Well, today we're diving into a scientific breakthrough that does just that. It's turning a super complex lab test into a simple, instant visual signal.
Okay, here's our game plan. First, we're going to get a handle on the real threat of mercury pollution. Then, we'll look at why we've been searching for a better test. After that, the fun part. We'll see the brilliantly simple solution, understand the cool science that makes it work, and finally, see how the camera in your pocket becomes a powerful scientific tool.
All right, first things first. Before we can really appreciate how clever this new sensor is, we've got to understand the problem it's up against. And it's a big one. That danger, of course, is mercury. It comes from all sorts of places: burning coal, making plastics, electronics manufacturing. It just kind of seeps into our environment, totally unseen, and becomes this massive global threat hiding in plain sight in our water. So here's where it gets really nasty. Once mercury gets into the water, bacteria get a hold of it and transform it into something even worse: methylmercury. This stuff builds up in fish, and when we eat that fish, it builds up in us. We're talking devastating damage to your nervous system, your organs. It can lead to horrific conditions like the infamous Minamata disease. And hey, don't just take my word for it. The World Health Organization, the WHO, they put mercury pollution right up there in the top 10 most serious environmental threats to our health. So yeah, the stakes here are incredibly high.
So you hear all that and you think, okay, if it's that dangerous, we must have easy ways to find it, right? Well, not exactly. And that's really the heart of the problem.
This slide just lays it all out so perfectly. Look at the left column, our traditional lab tests. Yeah, they're accurate, but they need massive, expensive machines. They're slow, you need an expert to run them, you have to take a sample and ship it off to a lab. What we actually need is everything in the right column. Something portable, cheap, instant, and so simple anyone can use it right there at the riverbank. And this is where the genius comes in. To fill that huge gap, scientists came up with a sensor that is just so elegantly simple. It all starts with this stuff right here, a special dye called a merocyanine dye. And as you can see, when you dissolve it in water, you get this amazing, vibrant pink color. No mistaking that, right? But, of course, it's not just a pretty color. This dye has been engineered to do something very specific and very, very useful when it meets the one thing we're looking for. And there it is, the magic trick. You add mercury ions to the solution, and that beautiful pink color just vanishes. Gone. It becomes totally clear. And what's so crucial is that it's picky. Other metals don't really do this. So you get this incredibly clear yes or no signal for mercury. It's either pink or it's not. Okay, so it looks like magic, but of course it's just really, really cool chemistry. So how in the world does this work? How does the color just disappear? The secret is a process called aggregation. Basically, in water, these little dye molecules are social butterflies. They don't like to be alone. They clump together into these little clusters, or aggregates. And here's the key. It's that huddle of molecules all together that creates the pink color we see. So what does mercury do? It's like the ultimate party crasher. The mercury ions come in and they break up that huddle. They force the dye molecules to separate from each other, a process called disaggregation. And once those molecules are all floating around on their own, they don't absorb light the same way. And poof, the pink color is gone. And look, we've got the receipts. This isn't just a theory. You can see it right here in the data. This graph shows us the size of those particle clusters. The blue line is our starting point. Now follow the red line. That's what happens when you add mercury. The particle size just plummets. That's the clusters breaking apart. But check out the green line. That's aluminum. It actually makes the molecules clump together even more. So cool. Okay, this is amazing. We have a simple visual signal. But how do you turn pink, or not pink, into a precise measurement? Well, it turns out the answer is probably in your pocket right now. This is where it all just clicks into place. The process is ridiculously easy. You add your water sample to the dye, you snap a picture of it with your phone. And then, using free software, you analyze the color in the picture. The more intense the pink, the less mercury there is. It's that simple. No lab required. But let's be real for a second. That's the big question, isn't it? Can a simple photo from your phone really compete with a $100,000 piece of lab equipment when it comes to sensitivity? Can it actually detect those tiny, dangerous amounts? The answer is, oh yeah, and then some.
They found the detection limit using a smartphone was 89.4 nanomolars. I mean, that is an absurdly small amount. But here's the absolute kicker. That result is actually better, more sensitive than what the same researchers got when they used a professional lab-grade spectrometer. A phone beat the lab machine. Wow.
So let's just boil this all down. What do we have here? We've got a sensor that's simple. You can literally see the result. It's low cost and totally portable. It's super picky, so it really only finds mercury. And best of all, it's smartphone ready. It just perfectly connects high-level chemistry with the tech we use every single day.
And that leaves us with this really powerful final thought. Think about what this kind of technology could unlock. This isn't just a new lab test. This is about putting the power of environmental monitoring into the hands of pretty much everyone: communities, citizen scientists, local inspectors. Maybe the future of keeping our water safe isn't some giant machine in a faraway lab, but a simple color change in a vial captured by the phone that's already in your hand.